Many of the changes to Section 300 of the L&D Volume 1 for this July update center around improvements the department has made to the process we use to plan, design, and construct ADA features such as curb ramps. Across the state, we've struggled to build these features to ODOT and PROAG standards. To begin with, we've put together an ADA reference website full of source information, references, and training guides. This website contains all the latest information if you have any questions or would like more background information related to any ADA issue you may encounter. Section 306.1.1 Exceptions to PROAG. Recognizing that there are some situations where the construction of an ADA compliant feature is just not feasible, ODOT has developed a waiver process for documenting these situations. These situations have arisen in the past, but we haven't formally resolved the noncompliance by reviewing and documenting the issue. Waivers may be granted based on the following conditions. Existing physical constraints include, but are not limited to, underlying terrain, right-of-way availability, underground structures, adjacent developed facilities, drainage, or the presence of notable natural or historic features. Disproportionate cost equals 20% of the project cost. Also, for features that are outside the project scope. For instance, if right-of-way would be required to construct a compliant ramp and no other right-of-way is being purchased on a resurfacing project. These conditions apply for alterations of existing facilities only, not new facilities. Section 306.1.2 Documentation Requirements. Waiver forms are required to document cases where an ADA-compliant curb ramp cannot be constructed. An electronic waiver form has been developed and can be found on the ADA website. This form should be completed and sent to a district design engineer for review when it is determined that a ramp cannot be constructed. This can be during the planning, design, or construction phase of development. A ramp with an approved waiver should still be improved to the extent practicable. Ramp slopes and cross slopes have been slightly changed to allow for a construction tolerance. Cross slopes changed from 50:1 to 64:1, and ramp slopes from 12:1 to 13:1. Waivers are only required where PROAG standards cannot be met. The title sheet of a set of construction plans should note the presence of any waiver on the project, and further details should be supplied in the general notes. Section 306.1.3 Documentation Retention. Approved waiver forms should be attached to the individual ramp in the ODOT ADA Collector app. This provides the department with a record of a waiver. For questions related to the Collector app, consult the District TAM Coordinator. Table 306-1, Sidewalk Grade Recommendations, was updated to reflect the change in slope and cross-slope values. Section 306.3.4, Curb Ramp Types. Ramp types were organized into tiers of preference and design. Designers should work their way down the tiered list with a diagonal ramp being the last choice after all other design options have been exhausted. Section 306.3.5 Detectable Warnings. Blended transitions and signalized driveways were added to the list of locations where detectable warnings are required. Section 306.3.8 Blended Transitions. There's been some confusion as to what a blended transition is, so we added a section defining one. It is basically a crossing where the sidewalk meets the street at a 5% or less grade. So these are very flat entryways. One big benefit to using a blended transition is that a landing is not required. Several figures were updated to the new slope and cross-slope values. These include figures 306-2, 306-3, 306-4, 803-2, 803-3, and 804-1. Section 904.2.1 ODOT Guidelines for Community Gateway Monuments. This is a new section addressing issues with communities wanting monuments at interchanges. The definition of a gateway monument is any community-funded, freestanding structure or decorative sign, non-integral or non-required highway feature that will communicate the name of a city, village, township, or county. A community gateway monument may include the officially adopted seal, slogan, date of establishment, graphic, or logo that has been associated with the community. Given within this section are location requirements, permit information, maintenance and maintenance agreement information, and removal conditions. The related information on what is allowed and not allowed is quite extensive and should be thoroughly reviewed when considering the approval of a monument. Figure 905-3, Guide for Landscape Planting at Diamond Interchanges, Figure 4. The revised Figure 905-3 shows planting and monument restrictions on the outside limits of a diamond interchange. Figure 905-6 Community Gateway Monument Checklist was added to provide detailed guidance on monument eligibility, including location, size, maintenance, utilities, and appearance. AASHTO released the second edition of the Guidelines for Geometric Design of Low-Volume Roads in 2019. The first edition addressed low-volume roads with 400 ADT or less. The new edition expands the definition for low-volume roads to minor collectors and local roads with less than 2,000 ADT. Since many of these roadways with low volumes also exhibit low crash frequencies, the new guidance gives designers flexibility by providing a recommended range of values for control criteria. Added guidance in Section 308.3.1 that shared lanes, also known as sharrows, can be used on facilities that have a legal speed of 35 miles per hour or less. On facilities with legal speeds of 40 miles per hour or higher, shared lanes are not a good idea because of the speed differentials between a motor vehicle and a bicycle. A WB67 should be the preferred design vehicle instead of the WB62 for roundabouts at interstate, freeway, or expressway ramps intersecting an arterial roadway if the truck percentages are high. Section 403.4.4.1 replaces design vehicle swept path with design vehicle tire tracking. The tire tracking is used to determine the curb locations at a roundabout. The swept path considered the tire tracking as well as the path of the truck, cab, and truck trailer. The swept path of the truck, cab, and trailer is necessary for vertical objects such as signs or poles, but not a factor in regards to curb placement. Tire tracking is more critical in curb placement. Section 403.5.1 provides guidance on the proper sizing of a roundabout. The preference is for the design vehicle to stay within the circulatory roadway. If this proves to be too extreme, then at a minimum, the truck cab should stay within the circulatory roadway and the truck trailer can track over the truck apron. This doesn't apply to mini roundabouts. Section 501.2.1.2 provides an additional limitation or disadvantage regarding the single-point urban interchange, SPUI. If a single-point urban interchange is built for an interim design year and will need to be expanded to the full build condition in a future design year, the construction costs for the expansion may be cost prohibitive. Section 501.2.1.4 provides an additional benefit regarding the diverging diamond interchange, DDI. The bicycle pedestrian accommodations can be provided with either a single sidewalk through the median of the DDI or two separate sidewalks on the perimeter. The benefit of using the median sidewalk includes fewer ramp crossings, and the motor vehicle's left turns onto the entrance ramps is no longer in conflict with the bicycle and pedestrian traffic. This figure illustrates the preferred bicycle pedestrian accommodation through the median. This figure illustrates the alternative bike pedestrian accommodation on the outside. Section 501.2.1.4 provides a design consideration regarding the diverging diamond interchange. The DDI may provide improved efficiency at the interchange intersections due to the two-phase signal operations, but it may expose inefficiencies and/or bottlenecks at the four-phase traffic signal operations at the signals adjacent to the interchange. This situation may have dissuaded the selection of a DDI as an option. However, retiming and/or rephasing at the adjacent traffic signals may allow the DDI to be a viable option. Section 501.2.1.4 provides a design consideration regarding auxiliary left turn lanes to the interchange entrance ramps at the diverging diamond interchange. The preference is to develop the auxiliary left turn lane prior to the upstream crossover to help avoid weaving movements between the crossovers to improve safety. This figure illustrates the preferred auxiliary lane development, auxiliary left turn lane developed prior to the first crossover. This figure illustrates the non-preferred auxiliary lane development, auxiliary left turn lane between crossovers. Section 501.2.1.4 provides several additional design considerations regarding the diverging diamond interchange. The design speeds for the crossover alignments should be at least 10 miles per hour, but no more than 15 miles per hour below the legally posted speed limit. The left turn lanes on exit ramps should have enough curvature to ensure drivers turn into the inside through lanes and not make a wrong way turn. The left turn on the exit ramps should be placed as close to the crossover as possible to reduce clearance time, all red, to improve signal efficiency.
Hello everyone, my name is Adam Koenig from the Office of Roadway Engineering, and I'll be going over the studies updates to Location and Design Volume 1. Throughout Section 400, there are various references to the new ODOT Analysis and Traffic Simulation Manual, also known as the OATS Manual. This manual can be found at the link below, as well as additional resources, such as the Model Documentation Form, Reviewer Checklist, Scoping Form, and some useful OATS training videos. A Transmiler database file for the entire state of Ohio can also be downloaded for use with Transmiler analyses. Section 401.2.1 Signals. The method for balancing intersections has been revised to allow for more delay on the minor streets instead of balancing the delay for the minor and major streets as before. This more accurately represents how the signals will be timed in the field after installation. The goal is to minimize the overall delay without having significantly unbalanced approaches. All individual lane volume to capacity ratios for both the major and minor street must be less than 1 and preferably less than 0.93. Section 401.2.3 Roundabouts. Sidra was previously used to analyze roundabout configurations that HCS could not analyze, but now Transmiler must be used to analyze these configurations. Sidra may still be used as an additional tool for analysis, but the reasons for use must be justified and approved by the Office of Roadway Engineering. Moving on to the Section 400 figures. Figure 401.14a was removed. This information can now be found in the OATS manual. Figures 401.14b, which included Sidra settings, and 401.14c, which included synchro settings, were left for reference, but these programs can only be used for supplemental results, and their use must be justified and approved by the Office of Roadway Engineering. These two figures will eventually be removed from Location and Design Volume 1 as ODOT continues to use HCS and Transmiler as its main analysis programs. As always, if you have any questions, feel free to contact our office anytime. Thanks.
The following presentation will describe the standards and specification changes for signing and markings that have been made in April and July 2020 specification updates. The point of contact for signing and marking specifications is Dwayne Soyson, who can be reached at the listed email address and phone number. During this presentation, I will be describing the recent changes to signing and markings, including 2 new warning signs, distracted driving corridor signing, decorative signs known as community gateway monuments, sign sheeting, overhead sign support design in LRFD, and the recessed wet reflective pavement markings program. Prior to implementing a two-way to four-way stop conversion, the public shall be given advance notice of the implementation by using a special sign. This sign, which is shown in the standard construction drawing MT 125.00, is to be provided in all plans which require the implementation of a two-way to four-way stop conversion. The sign design information can be found in the Sign Designs and Markings Manual. Similarly, prior to deactivating an overhead flasher, the public shall be given advance notice of the deactivation by use of special signing. This sign, which is shown in the new Traffic Standard Construction Drawing MT 125.50, is to be provided in all plans which require the removal of an overhead flasher. The design information for the sign can be found in the Sign Designs and Markings Manual. Because distracted driving poses an increasing danger to Ohio families, the Ohio Department of Transportation Highway Safety Program and the Ohio State Highway Patrol have been working together to establish distracted driving corridors to discourage distractions behind the wheel, as well as speeding, aggressive driving, and other dangerous behaviors that lead to crashes. 7 different signs have been developed for potential use within a distracted driving corridor, including safety corridor speeding and distracted driving, entering distracted driving corridor, safety corridor next X miles zero tolerance, X days since last serious crash it can wait. This could be your last text, and leaving safety corridor. Decorative signs have been recategorized as community gateway monuments, and guidance can be found in the Location and Design Manual, Volume 1, Section 904. A community gateway monument is defined as any community-funded freestanding structure of a decorative sign, non-integral or non-required highway feature that will communicate the name of a city, village, township, or county. A community gateway monument may include the officially adopted seal, slogan, date of establishment, graphic, or logo that has been associated with the community. To assist communities and their consultants, along with the district permit reviewers, a 40-point checklist has been developed and available in L&D Volume 1, 905-6. Type 11 sheeting provides better retroreflectivity over various distances and at wider angles. Changes were made to require Type 11 sheeting for the reflective legends, shields, arrows, and symbols, including the hazardous cargo plate, airport symbol, and borders on all extrude sheet signs, while background for these signs is required to be Type G. Type 11 sheeting is also required to be used on permanent object markers and end-of-roadway markers that use sheeting. The Office of Roadway Engineering has been working toward bringing ODOT more in line with the AASHTO structural standards by replacing the standard drawings that involve signal and sign supports in their foundations, utilizing AASHTO load resistance and factor design (LRFD) specifications for structural supports for highway signs, luminaires, and traffic signals. One major change is the deletion of the aluminum truss from the available standard construction drawings. To meet the fatigue requirements of the AASHTO LRFD LTS-1, the aluminum members would have to be made so large that they became essentially the same weight as steel, making them impractical. One other minor change includes a reduction in the available number of designs for cantilever sign supports from 12 to 3. The new design charts have been posted in the TEM, and I will show you an example in the next slide. All of the new drawings will have new numbers assigned to them. For example, TC 15.115 will be replaced with TC 15.116. 16 TC drawings have been changed. The new standard construction drawings shall be implemented on all department projects that have begun Stage 1 plan development after April 17, 2020. Projects further along in the development process should be considered on a project-by-project basis. This is the former design chart for cantilever signs. It shows 12 different design options. And this is the new design chart for the LRFD cantilever signs and shows a streamlined number of design options. In an effort to improve pavement marking performance, particularly during rainy night conditions, ODOT has implemented the Recessed Wet Reflective Pavement Marking Program. We started this summer with a pilot project that will install the recessed wet reflective markings in 10 different locations across the state. What we learned from the pilot locations will help us adjust our specifications for future projects. Beginning in the next year's construction season, the use of recessed wet reflective markings will be more widespread. All resurfacing and new construction projects on ODOT maintained interstates and multi-lane highways will use recessed wet reflective markings for the longitudinal lines. Also, all Class 1 work zone markings will be wet reflective. Since work zone markings are temporary, the extra protection of the groove is not necessary. All resurfacing and reconstruction projects on interstates and multi-lane highways should receive recessed wet reflective markings as their eventual final permanent pavement markings. Timing of when each project gets the recessed wet reflective marking is dependent on the completion date of the project. It is recommended not to include the recessed wet reflective marking in the resurfacing reconstruction plan itself if it has a late summer or fall completion date. Rather, those projects should include a lower cost standard marking, not recessed wet reflective, that will last through the winter and until the district-wide recessed wet reflective pavement marking plan installs the permanent markings. The Traffic Engineering Manual will be updated in the January 2021 to reflect these changes. 3 new specifications with respect to wet reflective optics have been published and should be used when appropriate. Supplemental Specification 807 gives instructions to the contractor for furnishing and applying wet reflective liquid applied markings. This should be called out on the title sheet when wet reflective markings are used. Supplemental Specification 905 establishes the material requirements for the wet reflective optics. Supplement 1103 describes the procedure by which the department will establish and maintain a list of approved wet reflective optics. To help protect the more expensive wet reflective markings, they need to be recessed in a groove. Supplemental Specification 850 is to be used with permanent wet reflective pavement markings. Ensure Supplemental Specification 807 and 850 are referenced on the plan cover sheet. That concludes the presentation for recent standards changes for signing and markings. Once again, if you have questions, please send them to Dwayne Soyson at the email address shown here. Thank you.
Okay, so here are some more engineering updates for July 2020 from the traffic control section. Specifically, the signals and lighting portion. I'm Kevin Dimmel, that's my contact information, so if you have any questions about these standards releases or any standards in general related to signals and lighting, you can contact me there. One big change this time, and that change actually took place in April. We moved all of our signal and sign supports in the TC series drawings to a new standard specification from AASHTO. It's the new LRFD LTS-1 specification that came out in 2015. There's nothing particularly wrong with our supports, but they needed to be updated to that specification, kind of a modernization effort by FHWA. So we went ahead and took care of that, hired a design consultant to help us out with that, and worked with the vendors and manufacturers to update our designs. We did eliminate a lot of extra design numbers that were in the old drawings that really didn't serve much purpose other than give us too many choices. So what is LRFD? Most people have probably heard of it. It's nothing particularly fancy, just a mathematical way of dealing with uncertainties in the loads applied and the resistance of a particular structure. So there's a little mathematical formula there. Basically says that the sum of all your loads with some factors applied to them should be less than or equal to the resistance or strength of the structure with a factor associated with that. And it's the factors that are kind of the interesting part. So for loads, those factors are generally greater than 0 because there's some uncertainty in the magnitude of the loads. And then for resistance, that number is usually a little less than 0. Less than 1. Because that accounts for some variability in the actual material properties and fabrication, other things associated with the structure. It's mostly just housekeeping stuff. Nothing has fundamentally changes in terms of the physics of the strength of the structure and resisting the loads. Most ODOT sign and signal support designs were pretty old to begin with, prior to this change, of course, and I've been able to trace most of them back to old Union Metal catalogs I found from the 1960s. There's a large selection of design numbers available in those early drawings, and moving from one design number to another, the differences in dimensions were actually pretty small at times, so it seemed kind of silly to have so many. Now over the years, we did tend to add design numbers as things got bigger. Arms got longer, roadways got wider, things like that. So we added even more design numbers. The original designs were based on what we call allowable stress design methods with a rather big kind of lumped factor of safety that accounted for all the different individual variables, including fatigue. Now LRFD, it's a little more modern approach to this. It isolates and sums up the individual load and resistance inputs rather than lumping them all together into one factor of safety. LRFD came out kind of in the 90s, I think. Even as an electrical engineer, I remember hearing about that when I was in school. So it's nothing new, but it is something new for us in roadway engineering to be applying these methods to signal and sign supports. So what follows is a real quick summary of the changes that we made to the drawings related to this compliance migration for LRFD LTS-1. We'll start with our foundations drawing. Now this is an interesting standard drawing because it refers to many other different standard drawings in the table below. So because most of the standard drawings for signal and sign supports that this drawing refers to changed, then this drawing itself had to change. This drawing used to be TC 21.20. In order to distinguish it with the new standards and everything, it has become TC 21.21. Now, what's interesting, again, one of our goals with this migration was to try to keep as many things identical to the old designs as we could, and we were pretty successful. Not everything is exactly the same. So there have been a few slight changes in the foundation details. Some of the anchor bolts have changed, maybe the circles or the physical size of the anchor bolts and things like that. So the changes can be pretty subtle. The table reflects the new drawing and design numbers that are available. And people have to be pretty careful, both designers and contractors, to make sure that they follow the right foundation table for the correct drawings, because the foundation in a TC 21.21 drawing is not necessarily the same thing for the same foundation in a TC 21.20 drawing. That was the previous edition. They can change very slightly, but a slight change in your anchor bolt size or circle could mean that the pole isn't going to fit. People need to be really careful with these new drawings. Now, one of the first signal supports that we run into in the series of drawings is the TC 81.10, now TC 81.11. That's our strain pole for span wire supports. This one has changed a little bit. I'm not going over any individual changes here. I'm just pointing out kind of the broad highlights. Not a whole lot of those changes are obvious. If you look, you'll notice there are more notes because we're pretty thoroughly documenting the design standards that we use so that in the future people are very clear on how the loads and stuff were arrived at for designing with this particular support. There's the second page. One of the interesting things that's happened with this particular design is that we've reduced the number of designs quite a bit. There used to be 14 of them. We had design 1 through 14. Kind of took a look at those and reduced them to 5. So now we only have 8, 10, and then 12, 13, 14. It's a lot cleaner and allows people to not have to choose between so many. Some of those were really small and almost never got applied anyway, so that's why you can see we kind of eliminated a lot of the designs that were on the smaller end of that range. Okay, the other big drawing for signals is TC 81.22. That's our rigid signal support, mast arm type support. Used to be TC 81.21, now it's 81.22. Here's the first page. It looks pretty much like the old one. Some additional notes, and if you were to look really closely, you'd see minor little changes in some details here and there. But it's basically the same thing. Like I said, there are some notes there to denote the compliance that we do. Now, we used to have 8 design numbers. We've reduced that to 5 in this case, so that's pretty helpful. And that's it for the signal supports. There were a lot more sign supports that changed, so hopefully Dwayne has covered that in his section of the webcast. Now, the only other really, there's only a couple other things that in this spec release that I thought deserved some attention. One, after a lot of discussion, would be I changed a little bit of the detail on the pull box lids, and we've always had a countersunk and flathead screw arrangement on the corners, which works reasonably well on day one, and then after that they get clogged up with dirt, and then people don't put them back in and stuff. So after a lot of discussion with the districts, decided to put a hex head bolt on the corner, and the old flathead screws are kind of gone. I did put a washer on there that's almost like a temporary feature. I'll make that optional at some point. That was there in case people wanted to use the old lids with the countersink in it. You can put the washer on there to keep the head of the nut from going down into the countersink. Not real clear on the drawing. I need to straighten that up just a little bit on the next release. But basically, we've gone to an external, ordinary stainless steel hex head type bolt on each corner, and that should be a lot easier for the maintainers to deal with, and maybe there's a good chance that they'll actually get reinserted after the pull box is used. Currently, right now, a lot of times people don't even bother putting the screws back in because there's such a problem, and so the pull box lid is just sitting there by gravity. All right, another change. This is a fairly big one, kind of a new item, or just it's the same item but kind of a new variation on construction method for the item. That's our power service. This is kind of a fluid drawing. Power services vary a lot with the location and the individual power companies and things like that. So this is traditionally a 2-page drawing, and it has become a 3-page drawing. We'll see what's happened. Page 1 is our traditional ground-mounted power service, kind of a schematic drawing there. This is basically a power service that's mounted on a strut frame that's anchored to 2 poles in the ground. Very traditional ODOT construction. The first page is what we call self-contained metering. That's where the current and voltage are both measured in the same meter enclosure with the same meter itself. Those are generally used for service voltages that are under 480, so it's fairly common. The next page is essentially the same drawing, but you can see it's grown an additional cabinet, that big yellow thing down there on the left. And that's what we call ground-mounted power service with CT or current transformer metering. And And that's generally a requirement for most power companies now for power services of 480 volts or higher, but the ODOT usually only uses 480. That's pretty common on some of our lighting installations. So we're going to start to see a lot more power service with this extra cabinet included in there. So I just went ahead and made a drawing for that. Now the new page is the next one. This is a new style of pad mounted power service. And these types of pad mounted enclosures are often kind of off the shelf devices you can buy. Millbank makes a lot of them, and they're popular with locals, especially in urban areas. Traditionally, ODOT didn't use them. They're not real good for our remote roadside locations because the weeds and grass can grow up around them and they kind of get lost. And there's a chance that they get hit with a bush hog or something while somebody's mowing. So we've never really endorsed this type of thing for our own use. But because the locals were using so many alternative designs that were kind of weak and thin and prone to rust, I decided that I would just go ahead and modify the design, and worked with our main vendor to build a ground mounted, pad mounted power service that used the traditional big thick stainless steel enclosure that ODOT likes to see for our control centers. And so that's this new design. Designers are free to use this. They would just call that out as a power service, pad mounted as per plan, blah blah blah, and refer to this drawing, and then the contractor would build it accordingly. And that's basically all the changes that I cared to summarize at this particular release. Once again, you got my contact information if you have any information that you need, and I'll be happy to provide that.
Hi, I'm Emily Willis. I'm with ODOT Central Office, Roadway Engineering. Chris and I both handle temporary traffic control items, and here is our contact information should you have any questions. These are the publication changes from both April and July 2020 that we plan on highlighting here today. First up are two sections in the TEM that have been added. 640-5.5 under use of shoulders, and then 640 12.5 under crossover construction. Both of these sections deal with drainage, the temporary drainage and inlets, and provide some additional guidance and considerations for when shifting traffic onto the shoulder or using a crossover MOT scheme. We updated Supplement 1021, which is the Aero Board pre-qualification procedure. We updated the minimum effective legibility distance to 1 mile to align with the OMUTCD in regards to Type C Aero boards. Prior to this change, it was 4,800 feet due to a field condition limitation during the NTPEP testing. This measurement limitation is no longer a factor, and current evaluations from NTPEP are coming in assessed to the full mile legibility distance now. At this time, we're not requiring those who are already on our approved list to go back and be reevaluated. Even under the prior evaluations, the product may have been legible at longer distances than the previously reported maximum of 4,800 feet. However, that was just the furthest the facility was able to measure at that time. So just because it was reported at 4,800 feet doesn't mean that that was necessarily the limitation of the unit at that time. We have added temporary pavement wedges at transverse joints and open travel lanes, paved shoulders to the drop-off standard construction drawing MT 10190. And we added that to address concerns with bumps caused during the placement of different pavement courses. We've limited this wedge to a 3-inch maximum thickness to coincide with the limitation of only using it with a single lift of pavement at a time. We didn't want a vehicle traversing through encountering multiple wedges in a series, stepping them up. We only wanted them to encounter one wedge at a time. We have selected different durations based on how long that wedge would be in place. And we've added that to the table. And that is the slope of the temporary wedge that we would be putting into place. Anytime they're paving the shoulder during the same operation as the adjacent travel lane, a temporary wedge is also required on the shoulder when the edge lines are not in place. In future publications, we plan to come back and address on-ramps and off-ramps, and then also some additional information in the TEM regarding a bump sign. The construction and material specifications has been updated to accommodate projects in the wet reflective marking pilot, where temporary wet reflective markings are specified for use. In January 2021, we do anticipate bringing forward additional publication changes to match the current wet reflective pilot guidance, which requires wet reflective for all Class 1 temporary markings. Grooving for temporary wet reflective markings is not necessary per the pilot guidance. In this slide and the next one, we have some clarifications, corrections, and cleanup work. So for this slide, we have two plan notes, TEM 642.8 and TEM 642.58. They're somewhat related. One is notice of closure signs, and the other one is notification of traffic restrictions. Both of them have somewhat similar tables for a portion, and the value for exactly 12 hours was not addressed in these tables, so we've updated them to ensure that 12 hours exactly is included within those tables. Due to changes being made by the Office of Traffic Operations for portable traffic signal detection, we needed to implement some updates in the MT Standard Construction Drawing 9611, which is a signalized closing of one lane of a two-way highway, in order to require non-invasive detection at each signal location, and then also to update some CMS references throughout the SCD. At the same time, we went through and we did update some other language simply to convert it over into active imperative mood. We continue to update our approved products list as items come in requesting consideration. And so here is a summary. The last couple of webcasts we've been providing the summary, so we've updated it again for this webcast. Current to August 7th of 2020. And you can see here in the light blue are the MASH compliant devices that have been added to the approved list as of now. And the dark blue are those NCHRP 350 compliant devices that either remain on the list or have been added just prior to going into the MASH compliant transition. The first in orange, where it has a plus and a number, represent how many have been added since our last webcast. And that was, I believe that was in February 7th, I believe. So in about the last 6 months, that's the numbers that have been added since that point in time. Please remember to keep checking our approved list as you go forward, as they will continue to change over time as we add more and more MASH compliant devices to those approved lists. The next two slides cover a few things that are coming soon. They're not formally completed yet, but we thought this was a good opportunity to start sharing some information here. So the first one is an update to the traffic management and work zones policy and standard procedure. One of the biggest changes for that policy standard procedure is condensing PIAC duties into the MOTEC. So anything that would have come forward to the PIAC previously still would need to come forward. However, MOTEC would be addressing those particular items instead of it being split off into the MOTEC and PIAC. And the MOTEC would continue to handle the same things that they had handled before. In addition to that change, there's a couple of other things. One being some clarifications regarding the district deputy director approvals and what's needed to be submitted and when submitted to MOTEC in regards to those district deputy director approvals. Also clarification of the applicability of the policy to ODOT maintained highways, as well as all federal aid highway projects, even if it's not ODOT maintained. And then the next grouping is once that policy and standard procedure is finalized, then there would be some changes coming forward for the TEM in regards to changing references to PIAC, to MOTEC, and whatnot. And last but not least is the permitted lane closure schedules. This is also coming soon. I know you've heard about this a few times in some prior webcasts. The work on this has continued. The system is complete. Right now we have the districts in there creating all of their segments and drafting all their 2019 schedules and getting them all prepared for publication. Soon they'll start creating their 2020 schedules and preparing those for publication. We are working through some hurdles with 2020 volume information being impacted by COVID-19, and we're making some decisions on how we'll use that data going forward. So we're hoping to have the system ready and launched by the first of the year, if not before then. So stay tuned.